History has just shifted in ways no one thought possible, and the shockwaves are about to be felt across the entire transportation industry. For the first time in aviation history, we are staring at a supersonic eVTOL that carries a price tag of only $75,999. Think about that for a moment. Until now, anyone who dreamed of owning an advanced electric vertical takeoff and landing aircraft faced prices well north of $1 million for a basic 4 to 6 seat model. That barrier made private electric aviation a fantasy for all but the ultra-wealthy. But Elon Musk and Tesla have once again done what critics said couldn't be done. By announcing the arrival of their new Tesla super electric plane, they've rewritten the rules, not just for flight, but for what it means to move across our skies. And make no mistake, this isn't just another experimental concept to be shelved in a lab. This is a project that has been woven directly into Tesla's next master plan. And it has now officially arrived. The timing could not be more perfect. Just as the FAA began loosening restrictions on private electric aircraft, Elon Musk seized the moment with a level of speed that stunned even seasoned industry insiders. Most companies spend years waiting for regulatory clarity. But Tesla wasted no time in rolling out a breakthrough that combines affordability, safety, and unprecedented performance. What makes this announcement truly mind-bending is not just the price, but the 3 enormous leaps forward that Tesla has quietly achieved behind closed doors. These breakthroughs have now been revealed, and they are sending ripples of excitement through the aerospace world. First, a propulsion system that delivers efficiency numbers no one has ever seen before, surpassing traditional aircraft by a jaw-dropping 347%. Second, adaptive wings that don't just stay fixed in place like conventional aircraft surfaces, but actually reshape themselves mid-flight to slash takeoff, drag by nearly 2/3 while maximizing cruise efficiency. And third, a cockpit design so radical that even veteran pilots are declaring it the beginning of a new era in flight. These aren't minor upgrades. They are paradigm shifts that will change how we think about personal and commercial aviation forever. As the world takes its first real look at this plane, it becomes clear why Tesla has managed to dominate industry after industry. They refuse to play by the existing rules, and instead they write their own playbook. Just as they redefined what a car could be, and just as they turned an energy company into an AI and robotics powerhouse, they are now rewriting the history of aviation. This super electric plane is no incremental step forward. It is the leap that skeptics insisted was decades away. And the fact that it comes at a price point lower than many luxury sedans makes it even more shocking. Tesla has taken aviation, stripped it of unnecessary complexity, and reimagined it through the lens of efficiency, affordability, and intelligence. So, how exactly does Tesla's propulsion system manage to achieve efficiency gains of more than 300% over traditional aircraft? To understand the scale of this breakthrough, we need to remember where aviation propulsion has been stuck for decades. Since the dawn of the turbojet engine in the mid-20th century, aircraft power generation has followed the same basic path: burn fuel, compress air, generate thrust, and repeat. Incremental improvements have been made, but the fundamentals haven't changed in nearly 70 years. Tesla's approach throws that entire framework out the window. Instead of relying on combustion, they harness distributed electric propulsion combined with electromagnetic thrust vectoring, a pairing that fundamentally alters how thrust is generated and controlled. In simple terms, distributed propulsion means that instead of 1 or 2 giant engines mounted on the wings or tail, Tesla's design places multiple smaller electric thrusters along key points of the aircraft's body and wings. Each thruster can be managed independently, distributing power with surgical precision based on flight conditions. This eliminates the inefficiencies of large centralized engines, dramatically increases redundancy, and allows the aircraft to continue flying even if 1 or more thrusters shut down. Add to this electromagnetic thrust vectoring, which uses fields rather than mechanical parts to direct airflow. And suddenly, you have a propulsion system that is not only more efficient, but far less prone to wear and mechanical failure. That's the secret behind the 347% efficiency improvement. It's not just about raw power, it's about how intelligently and precisely that power is delivered. To see how this plays out in practice, imagine a conventional plane lining up for takeoff. The engines spool up, burning massive amounts of fuel as they fight to overcome drag and lift the aircraft into the sky. Now picture Tesla's plane. Its adaptive systems calculate the exact thrust needed at every split-second moment of takeoff. The distributed thrusters fire in coordinated patterns, vectoring airflow in ways no human pilot could match. The result is smoother liftoff, with far less wasted energy, enabling the aircraft to reach altitude in a fraction of the time and with a fraction of the drag. And speaking of drag, this brings us to the second game-changing breakthrough, Tesla's adaptive wings. Traditional aircraft wings are designed as compromises. Engineers have to choose a shape that works reasonably well across all phases of flight takeoff: climb, cruise, descent, and landing. But what works for takeoff creates inefficiencies at cruising altitude. And what works best at high altitude is not ideal for landing. Tesla decided that compromise was unnecessary. By creating adaptive wings that can literally reshape themselves mid-air, Tesla has given the aircraft the ability to optimize its aerodynamics at every stage of flight. During takeoff, the wings adjust to cut drag by 64%, providing smoother and shorter liftoffs. As the aircraft transitions to cruising altitude, the wings subtly shift again, locking into a form that maximizes lift-to-drag ratio, squeezing out every possible mile of range while minimizing energy consumption. This is not science fiction, it's the result of smart materials, embedded actuators, and AI-driven real-time aerodynamic modeling. No other company in aviation has been able to achieve this level of adaptability without introducing insane costs or mechanical complexity. Tesla, leveraging its mastery in advanced materials and AI software, has made it not only possible, but affordable now. Let's step inside the aircraft, where the third breakthrough reveals itself. The cockpit is unlike anything aviation has seen before. For decades, cockpits have been dominated by dials, switches, and human limitations. Pilots undergo years of training to master the complexity of controlling an aircraft. And even then, human fatigue, error, and limited reaction times remain constant risks. Tesla has eliminated these limitations with a cockpit that is less a control center and more an intelligent co-pilot. The design is streamlined, dominated by augmented reality interfaces, holographic displays, and full AI integration. Instead of the pilot manually juggling throttle, flaps, and instruments, the aircraft's onboard AI handles everything with real-time precision. Human input is still possible, but the AI's ability to respond instantaneously to atmospheric changes, traffic conditions, and navigation challenges makes human error almost impossible. Seasoned pilots who have tested the system are calling it revolutionary, describing it as the first cockpit in history that truly feels like the future rather than a relic of the past. By eliminating human limitations, Tesla has made aviation safer, smoother, and far more accessible. But Tesla didn't stop there. The most radical idea embedded into this plane is something Musk has called the atmospheric highway system. For decades, roads and highways have dictated the flow of human movement. But in the sky, the air has always been seen as chaotic, unstructured, and unpredictable. Tesla's atmospheric highway changes that by overlaying structured flight corridors powered by AI and connected to the broader Tesla ecosystem. Imagine invisible highways in the sky, with lanes, traffic management, and predictive routing, all coordinated by a neural network that prevents collisions, optimizes routes, and ensures aircraft can move with the same order and efficiency as cars on a freeway, only faster, smoother, and without traffic jams. This is the future Tesla is building, where the skies are no longer the Wild West, but a structured, efficient, safe, and universally accessible transportation grid. Once fully rolled out, this system has the potential to make private electric aviation as routine as driving your car to work today. What we are witnessing here is not just a new aircraft, but the birth of a new era. Tesla's super electric plane isn't an isolated product, it's the beginning of a transportation revolution that will spill into every sector. From personal travel to cargo, from emergency response to commercial airliners, the principles behind this plane will ripple outward. forcing competitors to abandon their outdated designs and embrace the future. And all of this starting at a price point under $80,000 is something that no one thought possible. The disruption is real, and it is already here. This is why insiders, early adopters, and aviation enthusiasts are calling it the most significant leap forward since the dawn of the jet age. So if you want to be among the first two, let's witness this transformation. Now is the time to pay attention. Over 215,000 people have already